In Google's latest breakthrough, its researchers from DeepMind have just demoed small, humanoid robots that can play soccer at an astonishingly high level, using a series of advanced AI techniques. But there's a twist in fact. These small androids can run circles around other, manually programmed robots, displaying agility, strategy and skills to outperform most others. At this project's core, one single goal stands out: to create general-purpose robots that are capable of mastering complex, physical tasks and soccer with its constant motion, quick decision-making, and blend of individual skill and team strategy provides the perfect test bed. Now enter Valkyrie, which is a 60-centimeter humanoid robot that has 20 articulated joints, its own onboard computing power and an agile frame. As Google unleashed its full potential on using deep reinforcement learning for the AI agents to teach themselves in simulation, and the results were shocking. First, the robots honed their fundamental skills in the simulation by standing up, turning and kicking, with the realistic physics of Google's Muyoko engine serving as their virtual playground. But then, in order to prepare for the real world's unpredictability, the simulations began adding disruptive forces and random events, forcing the robots to adapt through trial and error. Once their basic technique was solid, the robots were ready for full soccer matches against increasingly formidable AI opponents. And with every game, they learned new tactics, from anticipating the ball's path to blocking shots and even combining moves to score. The AI was rewarded for goals and penalized for reckless challenges in order to formulate a sophisticated understanding of a one-on-one soccer match. And when these AI agents finally took their training to their soccer field, their performance was extremely beyond what was anticipated. For example, compared to traditionally programmed robots, DeepMind's AI agents ran 181% faster, turned 302% quicker, stood up 63% faster after falls, and kicked a blistering 34% harder, using their small bodies with the utmost efficiency and power. But raw athleticism only tells half of this robot story, because these humanoids also displayed an intuitive grasp of the game's tactics and dynamics. Additionally, they even calibrated their stride to manage the flow of the game, combined skills to increase their scoring chances, and defended with intelligent positioning, all without explicit coding for any such situations. And DeepMind sees this progress as merely a stepping stone to an even grander vision, composed of general-purpose AI robots that can learn almost any task with minimal human guidance. To this end, soccer serves as a trial phase in which foundational motor skills and strategic reasoning can be forged. Ultimately, though, this research is part of Google's long-term goal to bring robots into everyday life in a way that is helpful, powerful, and safe. And already the team is exploring how the robots could learn directly from vision, eliminating the need for motion capture, and the implications extend far beyond sports. For years, Google has been working on intelligent robots like its RTX, but this work goes even further. This is because if DeepMind's approach can help robots do something as difficult as learn how to play soccer, just imagine how much more useful they'll be in fields like healthcare, manufacturing, logistics, and search and rescue. These machines are quickly mastering the most intricate physical routines of humans and animals, seamlessly blending multiple skills together to achieve a growing number of complex tasks. But most importantly, DeepMind's research team observed that the robots executed movements with greater fluidity compared to those trained using other methods. Additionally, DeepMind's AI even mastered strategies like feigning a turn to trick opponents into overreacting, to create openings for making a goal. In comparison, other larger AI-powered robots are still developing in terms of their speed and ability, with these robots already working in warehouses and electric car factories, doing tasks that don't require much speed or dexterity. But by the end of this year, that's set to change. While Google hasn't unveiled any commercial plans for humanoid robotics, it's very likely that this tech is being developed for the purpose of integration into tomorrow's Google products, and these DeepMind AI agents could very well be the foundation for the next generation of intelligent machines that inevitably exceed humans in every facet of physical performance and intelligence. But that's just the beginning of the latest AI and robotics breakthroughs, because meanwhile at NASA, an extraordinary robot named Valkyrie is hard at work, training for one of the most important missions in history, space travel. This towering 6-foot android may one day accompany human astronauts to the moon, Mars, and beyond, taking on crucial tasks too dangerous or strenuous for people Most importantly, Valkyrie's artificial intelligence lets it reason and make decisions like a human. And the NASA team believes that with the right AI software, Valkyrie could eventually function at the level of an expert human assistant. To this end, the robot is currently learning skills like repairs, construction, piloting spacecraft, and anything else that an astronaut might need help with on long space voyages. In fact, Valkyrie will even be able to leave the ship and work on exterior tasks. For example, in one simulation, Valkyrie single-handedly ran the systems on a lunar lander from start to finish. Perhaps most impressively, Valkyrie can instinctively understand and use any human-made tool or machinery thanks to advances in robotic vision, spatial mapping, and predictive movements. This means the robot doesn't need any programming, but can instead just look at a tool like a human would and decide how to best pick up and use it. Furthermore, Valkyrie combines its immense physical capabilities with state-of-the-art sensors and computing power. Specifically, its head contains the latest sensor suite from Carnegie Robotics to generate 3D environmental mappings, as well as detect hazards and obstacles. As for the robot specs, each of Valkyrie's arms has a total of 7 articulated joints, powered by rotary and linear actuators. The robot's hands mimic the human form, with 3 fingers and an opposable thumb, providing incredible dexterity to grasp and manipulate objects. Quick-release joints in the arms and legs allow Valkyrie's limbs to easily detach for shipping and repairs. The torso houses not just computer systems, but 2 actuators controlling pelvic rotation and tilting of the upper body. Speaking of which, Valkyrie's legs contain a total of 5 rotary actuators per limb, enabling the robot to walk, climb, and pivot with precise human-like motion. Even the ankles utilize linear actuators to balance and shift. Valkyrie's considerable 235 pounds mass overall, Valkyrie represents the cutting edge of robotic design, combining human-level mobility, sensor integration, and electronic intelligence. But one of Valkyrie's biggest advantages over humans is its raw durability, which NASA has basically engineered to be indestructible through simulation tests, mimicking extreme planetary conditions, such as scorching heat, radiation, storms, and toxic atmospheres. Valkyrie has proven it can withstand the harshest space environments, so that humans won't have to. In various demos, NASA's robotics team has been putting the robot through rigorous training exercises to get it mission ready. It scales rocky landscapes, fixes broken equipment, and operates control panels, completing all of the complex tasks it'll face on the Moon and Mars. Overall, the Valkyrie robot appears to be developing at a reasonable pace, but will it be enough to stand up against the competition as the robot revolution unfolds? The answer will quickly become clear.